Let's call these 2 points on the top circle where the slice intersects the top circle. We'll call these 2 points C and D. Then I'm going to drop a perpendicular down from C and D to the bottom circle to these corresponding points C prime and D prime. Now we're going to take a look from the top of the cylinder. So it will look like a circle. Here are points A and B. These are points C prime and D prime, also on this bottom circle. And these 2 chords are parallel to each other. We can think of this shape A, C prime, D prime, B, and then back to A. We can think of this as the projection of this unpainted face onto the bottom circle of the cylinder. So we're going to find the area of this yellow region and then multiply it by some stretching factor to get the area of the unpainted face. Let's draw this top view circle again. We're given in the problem statement that this arc from A to B is 120 degrees. So I'm going to say that the center of this circle is O. So this central angle is 120 degrees. This slice passes through the center of the cylinder. So the segment BC prime, which is the projection of segment BC onto the bottom circle, also passes through the center of this bottom circle, so it is a diameter. So this angle up here is supplementary and 60 degrees. The radius of this circle is 6, and we have triangle OPC prime is a 30, 60, 90 triangle. So this is 3, and the distance from C prime to P is 3 root 3. Finding the area of A, C prime, D prime, B, we're going to find the area of these 2 60-degree sectors that are congruent to sector A, O, C prime. And then we have 2 congruent triangles. O, C prime, D prime is congruent to the triangle on the other side. These 2 sectors and 2 triangles are going to give us the area that we need. This is 1/6 of a circle with radius 6, and this is 1/2 base times height. So the area of this yellow shape is 12 pi plus 18 root 3. Let's redraw our cylinder, and again we note that the area of the shape that we found, A, C prime, D prime, B. This shape is a projection of the slice ACDB onto this bottom circle. So ACDB is basically a stretched version of this projection, where we replace our segment BD prime with this longer segment BD. The distance from B to D prime, it's the triangle that was part of this 60-degree segment. We have triangle BOD prime is equilateral, so the distance from B to D prime is 6. The height of our cylinder is 8, which is also the distance from D to D prime. We have a right angle here at D prime, so the distance from B to D is 10. So we're replacing this distance from B to D prime, a length of 6, with a length from B to D of 10. And everything else about this shape stays the same. So if we stretch our projection A, C prime, D prime, B by a factor of 10 over 6 or 5 over 3, and this is in one direction, so we only multiply once, then we will yield the area of ACDB. So ACDB is 5/3 times the area of A, C prime, D prime, B, which we found earlier, 12 pi plus 18 root 3. This is 20 times pi plus 30 times root 3. The problem asks for the sum of A, B, and C, and our answer is 53. If you'd like me to solve any other math contest problems, please leave them in the comments.